Does everybody
Great.
have to consent to that?
I'm not sure actually. Throw it in the chat window, guys. Do you all get prompts to have to consent to recording? Yeah, everyone does. Wow. I wonder what happens if you say no. Do you have to leave?
That's a
I'm
really
not sure
good
what.
response. I love it. Look
Yeah.
at that, man. You got power.
Dude, the chat window is awesome. Yeah, I think we've had pretty good dialogue so far, I think, in the class. It's great. Hopefully students feel the same, that your voice is heard.
Oh,
That's
you have to
definitely how we
leave
want.
the meeting if you I guess if you don't consent
Yeah.
to being recorded. How about that?
Wow. Very interesting. Cool. All right, well, welcome everybody. This is lecture number 6, and it's our first guest lecture of the year. I'll give a nice intro to our guest lecturer pretty soon, Tony Fast. I'm really excited to have him here. So welcome everyone to lecture 6. I'm sure as you've seen, we had some announcements from the chancellor recently about how we're going to handle getting back to class, and there's going to be these 2 days where undergraduates are going to be kind of off so they can, I think, move. I haven't had a chance to catch up on that yet today. This afternoon, we will look at it. The TAs and I will meet, and we will let you know what our policy is going to be around that. We'll try to be, as always, as accommodating as possible. We understand that this pandemic is pretty crazy, and we are here to support you and work with you. We just want you to learn some computer vision along the way. So please just let us know how you're doing, and we will announce what our policy is going to be regarding that announcement from the chancellor. Great. Okay, cool. So I'm going to go ahead and toss it over to Arvind and Rohan. They're going to give a quick auto lab update, and they'll give just, if there's any other announcements, they'll run through those quickly. So I'll hand it over to you guys.
So I think Autolab is working fine. Hopefully nobody has any issues so far, except for a few issues that were put up on Piazza, and we have given our answers regarding that. Do you guys have any other questions regarding Autolab or facing any difficulties?
I guess there's one question by Vaidahi over here, Professor. If you could look it in the chat window, it's at the top.
Yeah, so my code is taking about 45 to 55 seconds on Autolab, but Autolab it timed out. Okay, and just remind me, guys, so I think we're giving 180 seconds, is that right, on the evaluation server?
Yes.
Okay, yeah, so that should be kind of on the window of what works. Arvind and Rohan, did you have a chance to time your code locally? Do you know about how long it's taking you to run on your development laptops?
On my machine, it goes over around 70 seconds.
70, okay. Mm-hmm.
Yes, and I don't know, magically it times down it to 67 seconds or something on Autolab.
Okay, gotcha. And Videhi, who asked the question, you've tried one submission so far, is that right?
Yeah.
Okay.
Yeah.
Cool. All right, Videhi, I'd recommend submitting again and see if you get a different outcome. If it's that quick on your machine, you should be okay, unless you have some like crazy multi-core super fast computer we don't know about, and maybe that's biasing your number or something like that. Most of the code does not use multiprocessing anyway, but I'm not sure. Maybe there's some difference between your computer set up in the evaluation server, but I would try again. If you run out of attempts and you can show us that your code is indeed working and taking only that amount of time, we can give you more attempts, or we'll figure something out to help accommodate. But I would recommend submitting again. What do you think, Arvind and Rohan?
Yeah, we can do one thing, like we can download her submission, put it on our local machine, check her code, and if everything is good, then we can move ahead.
Okay, great. And would you like Videhi to talk to you on Piazza about that, or to email you directly?
I'll speak with her on Piazza or through emails.
Wonderful, great. All right, thank you, Videhi. Hopefully that helps. Okay, great. Any other announcements from Arvind and Rohan, or any other questions before we hop in?
We have a quiz on Monday as scheduled, so it would be on 28th, and you can take it at your own time. So far, that's what we have decided. Like the quiz would be around 20 to 25 minutes, and you have 5 questions. Yeah, and it's a combination of multiple choice questions as well text-based questions where you need to type your answers. Yeah, that's it.
Great, thanks. Yeah, and just a quick thing, I'll hop in real quick for preparing for the quiz. The best thing to do by far is to go back to the notebooks and all the multiple choice questions I asked you in class, everything that was a poll. Those are the best things to study. Usually the quiz questions are going to be kind of slight variants on those. So we're not trying to trick you, nothing like that. Just trying to test your understanding of the big key concepts that we covered in the lectures.
So, on September 28th, you can start your quiz at any time, but after you start, you have around 20 to 25 minutes to complete it.
Right, and that will be through Canvas.
Yeah.
Great. Okay, cool. Any other announcements, guys?
That's it from my side, Professor.
Cool. Anything from you, Rohan?
Just one thing, please do not forget to submit your codes on Canvas as well.
That's right. Thank you for bringing that up. Yeah, so we use the evaluation server to give you a quick score, but your official submission is on Canvas. The reason for that is our evaluation server is a little bit rogue. It's not part of the official university setup. So your official submission is through Canvas, because if we have any disputes or complaints or problems or any plagiarism issues, we have to have a record on Canvas. So, so yeah, also submit your final code to Canvas.
That's so silly. Open
I know,
source
man.
is just plagiarism.
Isn't it? I know, man. I know. Yeah, but I've gone back and forth over what our plagiarism, policy should be. It's probably a cool conversation we could have. But yeah, there's a lot of discussion to be had there, I think.
Oh my God, that's so like non-scientific. It's so uncollaborative.
It is.
Like, my model's going to win.
Yeah, right. And most of our stuff is collaborative, but we do have our programming challenge. We do require your own code, basically. Okay, cool. All right, great. Well, let me do a quick screen share, and I will give Tony a quick introduction, and we're going to hop into it. So let's see here. So just so we're all on the same page, here is the course schedule. Here we are on the 24th. We've got our first guest lecture, which is great. The first things are just starting to be due now. So your project stage 1 is due tomorrow night at midnight. Do include your resumes. That is part of what we're looking at as we group you into groups. So I see a question from Monica. She says, do we need to submit both the sample student.py file and the evaluate? So Arvind has responded, yeah, we just need the sample. We just need the sample student.py. The evaluate is what we're going to use, so we don't need that file. Good question. Yep. All right, cool. So yeah, here's where we are. And just to kind of close it up here, we're about to hop in, like I said, but I kind of want to show Tony real quick what we're working on. So just so you know, Tony, what they're doing basically is writing code to tell apart images like this from images like that from images like that, right? So that's the first programming challenge. And voice is Poppy. Okay, let's see here. How is it now? Any better?
It's still a little grumpy.
A little grumpy? Okay. This headset has been good so far. We switched to it recently. Let's see. How about now? Oh, you know what I should do? I need to turn off video, basically. Yeah, I'm going to turn off video temporarily. I'll turn it back on when Tony and I are chatting, but okay. How is that?
Indeed
better. I bet it started getting better or bad because I'm showing a video on screen, which takes more bandwidth, so I lost bandwidth for audio. There you go. All right, so that's the programming challenge, and we left off last time, guys, with the Huff transform. So you now have this great tool invented by Paul Huff to let you take an image of a brick like this, compute the edges, go to the Huff parameter space, find the maximum points where those lines intersect, and use those to compute best fit lines. So that's where you are. I'd recommend trying that on your programming challenge. Put questions on Piazza, and your programming challenge is coming up. So if you haven't started spending time on it, then now is definitely the time. I think we have, how many submissions is it, guys? Like 12, something like that?
Around 11 or 10.
11, yeah. Cool, and the top score is 72 right now, so the first place person is at 72, and we are offering a $10 Amazon gift card. So if you get first place, that is what's at stake.
School's weird.
It was funny. I did it kind of just for if you want to compete for the top spot. Just a little fun. Just that part's for fun, right? So it's pretty easy. It's not too hard to get a 10 out of 10. But then if you want to compete a little bit, you can. All right, cool. All right, great. So that's what we're doing today. And let me turn off my screen share real quick and just give a quick introduction to Tony. So let's see here. Share. Okay, cool. Share is off. My video. Cancel. Now, can I get video going? Maybe. Okay, I think it's coming. All right, there we go. Cool. Okay, great. So today we have Tony Fast, our first guest speaker. And I just want to tell a quick story before I throw this off to Tony. Hopefully he doesn't hate me for telling the story. But it's just about my background a little bit. So like back when I was in undergrad, I actually really hated like programming. I thought it was like really dumb. Because in my mind, like what software developers and programmers did was like they just sat in cubicles all day and just turned like specifications into, source code. Like that's what I thought programmers did. And I wanted like no part of it. It sounded really boring. But kind of like when I got into grad school and started working on research problems, I realized that programming is actually like probably one of the most important tools that we have invented as humans, right? And that there's a bunch of ways to approach programming, and there's like it's really just like a medium, like it's a tool, right? And there's really creative, interesting ways to approach programming. And whenever I hear Tony Fast talk about stuff, it really reminds me of that, right? So that's something that I really enjoy when I talk to Tony. So I'm sure that's going to come through today. So just keep that in mind. I'd say today, as you're thinking about, I know you're in the middle of course and a pandemic, but as you're kind of thinking about your career, right? Like, what do you want to do? What kind of things are interesting to you? Just know that there's a lot of different ways to approach the kind of stuff we're doing in this class, and you're going to get one approach from me. But you're going to get a really cool, unique approach from Tony, right? That's my opinion, at least. Hopefully, I'm not embarrassing him, but I think he has a really cool approach to this kind of stuff. So get excited. Today he's going to talk about science, data scientist, Jupyter open source, data frames. He's got a really cool background in this stuff. That'll probably come up. And we're going to start just kind of with some questions, and Tony might share some code and walk through some stuff. But that's the idea for today. So I hope you enjoy it. We're not going to be quizzing you or anything on the topics from today. I hope it's just a chance to see some different perspectives around the kind of work that you may be doing one day or the kind of projects you may be involved in. And I hope you enjoy it. So with that, please join me in welcoming Tony Fast. We can't really clap. You could type clap maybe in the chat if you want, something like that. I'm not sure. But thanks for joining us, Tony. Oh, I got a clap. Yep, there we go, Thomas. Thank you.
Yay! Yay!
All right.
That
Awesome.
was a delightful introduction, man. Thank you so much. Let's see. I'll know if I wanted to do one of are you guys doing circular Huff transforms? They're like my favorite.
Oh man, yeah. Well, we just did the linear Huff transform, but students are able to code up their own circular if they would like as part of the challenge. I know some students have done it in the past. We didn't have time to cover it in lecture, but yeah, it is out there.
Yeah, it's such a. I used to. Let's see. I think that this is like my old SlideShare. So one of the projects that I worked on like a really, really long time ago. I don't know if you can kind of see this image right here, but these are like little fibers with little dots in them. And it's actually like a 3D sample. So all of these fibers go through, and what we were doing was we were using circular Huff transforms and with different radii and filters to be able to kind of look at like carbon fiber and stuff like that going through different materials. I love that you guys are doing this like the hard way instead of going right into the deep learning stuff.
Yeah, man, absolutely. When you did that project, where did you get your Huff transform? Were you able to just kind of get it out of a library like OpenCV, or did you have to kind of hack it together yourself a little bit?
Oh man, no, I wrote that in MATLAB in like 2008, 2009. Yeah. I mean, it was back, MouthWorks Central wasn't even much of a thing. But yeah, it's funny. I say I'm like the worst data scientist ever. I've been fired from so many data science jobs, and I've had like people with data science degrees interview me for jobs, and they've been kind of jerks to me because like it wasn't a thing for me, right? And they're like, "Oh, have you done this thing?" And I'm like, "Probably. Can I read your code?" And it's I haven't done all that well, but yeah. We wrote these things ourselves. Originally, it was doing image transforms, but then eventually you want the speed and you're writing the Fourier transform approach and, doing convolutions and things like that. So, it evolves too, right?
Yeah. Yeah, that's awesome. That's super cool. Yeah, we don't get to cover the Fourier transform in this class, unfortunately, but we do the Huff transform, and we'll do a bunch of convolution stuff. And you guys actually should already be somewhat aware of what convolutions are. We were doing the cross correlation instead, but you will have a cross correlation question on your quiz, so it's super relevant.
Oh man, that statistical space is like one of the best feature spaces you can ask for. Like the cross correlation,
right.
That bit, like especially if you can get like a good feature, like continuous feature descriptor on top of it, like a Legendre or Chebyshev or something. Like that's like I love seeing elegant machine learning data science applications that are like, okay, we have a statistically sampled space, and we're going to do it this way instead of throwing all this compute at it. It seems terrible.
Yeah, so part of what Tony's talking about, I think, if you guys don't know, so right now we're definitely in this big kind of, I would say, like data science is really trendy right now, right? So we're in this big, I think we're in the third wave of AI basically, right? So there's been two big waves of AI, once in the 60s, once in the 80s, and now we're in the third one. And everyone's really excited about deep learning, which is great, right? But you know, hopefully one thing you get from this class is that like the deep learning is important, but it's about what you can do with it and kind of the context around it and the other things you're able to bring to it. And it's also somewhat I think about first principles. Like deep learning is not just like a magic box and it can't solve every problem, right? So I hope that's part of what comes out of the class by the end. It's tempting just to throw you guys deep learning right at the beginning because it is so popular right now. But that would be doing you a disservice, especially like 10 years from now when we're not in the same AI kind of bubble, I think.
Oh my God, the access to resources right now is so privileged, right?
Yeah.
Like it's not there's no way that this energy footprint is sustainable in the way that it is right now too. And also the thing that worries us, so, you know, I probably should say where I work. I work at Quansight.
Sure.
Yeah, I work at Quansight, Quansight. But we do consulting with open source scientific computing. So part of our gig is like we have clients and we give them open source solutions, and then part of our responsibility is to maybe make some upstream changes to the library, you know, just kind of like adapt stuff that way. We also have a research laboratory that's fully focused on, you know, so we are focused on supporting NumPy long-term, SciPy long-term. We're making sure all the maintenance happening, diversity inclusion efforts and stuff like that. So, you know, I think it's important to kind of mention that I'm all around this SciPy, open source, Jupyter kind of space. I make commits to like IPython and Jupyter. I do a lot of like community work and stuff like that. So if anybody has any questions while we're going through this, please.
Yeah, if you have anything about Jupyter, and maybe Tony, if you don't mind, I'm not sure I don't think we've talked about this. Could you give just a brief history of IPython and Jupyter for, I think some of our students are coming in and it's their first time using Jupyter, right? So
yeah, sure.
Yeah, that'd be awesome.
All right, great. So yeah, let's do it this way. Computer vision lecture. Tony goes over here. Allow. All right. So Fernando Perez is your guy. He's the prophet of IPython. And he actually has a really good article about the history of IPython. You know, this history goes very far back to like Xerox PARC and, you know, I mean, you talk about three waves of AI. When I think about this, I think about modernism, postmodernism, and, you know, sort of where we are now and how all that stuff's kind of impacting us. But there's a historical retrospective here. There have been some notebook ideas that have come before. We've been designing them since like the 1980s or so. They were originally designed at Mac. And there's also, I'll share these links in the Zoom, or somebody, maybe we could crowdsource these links or something like that, or there's a place where we can put these things. I'm gonna give you guys a lot of good reading and stuff like that. End of Science, and I think that this was the Atlantic. This has another good one, which, nope, not If You Menstruate, the Atlantic. This, you know, doesn't it suck when you're like, oh, Stephen Wolfram's in the news, and it's like, oh, that's not going to be any good.
Yeah.
But he's in here being a little bit mean about Jupyter Notebooks. Yes, the scientific paper is obsolete here. So this one actually goes into a really good discussion about, like, it starts in the 1600s, so it covers a pretty broad scope, where some of the original notebook ideas came from, where the original designs were, Stephen Wolfram, Mathematica, and stuff like that. I mean, did you ever use Maple, Stephen?
Very briefly in undergrad.
Right? Yeah, that's where I cut my teeth at, learning how to do this stuff.
Nice.
But yeah, it was a good tool. Yeah, I mean, one of the I'm not going to tell you so much about the history. You can follow through it here. But what I think is important in general in open source is history. You know, these are open communities, they're transparent communities, and when you meet a new project, you'll learn the ability to use the code, but you'll also have to learn to analyze whether or not to use these things. And one of the ways to do that is read the history. If you're going to use Spark, read the history of Spark. They cleared that up, though. a while ago it said it was like started by some like high school interns at like Stanford.
Oh my
And then they
gosh,
cleared
that's
that up on Wiki. But yeah, you know, learning the history of why Dask exists, learning the history of
right,
why NumPy exists,
right.
all of these like historical contexts, like they come from the scientific domain. And I mean, as people
Right.
are leaving academia, you know, more and more folks are open sourcing their science. So there's
Yeah.
some historical context to glean there.
Yeah, absolutely. And I definitely want to talk more about open source for sure. And just so that was an awesome overview, and just the more recent history, right? So I know that the IPython notebook, right, kind of came out when I was just getting into Python. It was like 2012, something like that, I think.
Mm-hmm.
And that became basically the Jupyter notebook, right?
Mm-hmm.
And Jupyter is that maintained by Quonsent today, or?
Mm-hmm. No, so Jupyter, I mean, it's a global project. It's
Yeah.
you know, they won the ACM award, the
Yeah.
Software Systems Award, right? So
Yeah.
I don't know if y'all are familiar, but I should probably share again.
Sure.
It's just we're just gonna keep bouncing from screen to screen.
That's okay.
You know, and hey, you know, if one person reads this and talks about it, it's a good thing. But
Yeah.
the ACM Software System Award.
Mm-hmm.
Let's see. It's definitely one of the more. There's a Wikipedia for it. So I mean, Jupyter is in good company, right? You know, Jupyter's up here. Wireshark's cool. Eclipse is like the best IDE that we've made so far. Java's
Right.
on here. Apache. World, you know,
Right.
I mean, they're in good company here, and basically the
Yeah.
idea is that, you know, if you win this award, we think that your software is here to stay. And like,
Right.
I don't know how you feel about it, but like, if you started in 2012, you were an early adopter of this technology, and you know, people would rag on it over the years, but like, it feels good to have like made the right bet, kind of.
Yeah, absolutely, man. Yeah, and you see resistance and people are ragging on it. And maybe just for the students who don't know exactly, like what are the alternatives to the Jupyter notebook, right? Like what are the other ways to do things, right? Like why, you know, if Jupyter didn't exist, right? Like why is it important, you know? Like why does it change the way you think or the way you work, you know?
Oh, Christina, do you use Spider?
Oh yeah.
Yeah, that's awesome. We actually, so at Quantight Labs, we've got it seems like quite a few folks do. So we actually have a bunch of developers from the Spider team working at Quantight also. So there's really good, again, diversity inclusion efforts going on around that stuff. It makes me super happy to see that y'all are using that. I know they've been figuring out how to use notebooks in there recently too. It's interesting. There's a geographical phenomena with Jupyter and Spider because there's a lot of developers in South America, so it's very common down there. Meanwhile, you know, Jupyter kind of takes a little bit more prominence in the States.
Right.
But let's talk specifically about Jupyter and its importance. I guess it was only really fringe programming concepts that existed before that had this idea that your narrative and your computation should be woven together.
Right, right, yeah.
And, you know, Jupyter was really the first one to do that in a data format. I mean, most of the things before it were XML. They came in right at this like modern web time, and they could encode things in JSON. But like, I think ultimately, you know, Jupyter notebooks have this ability for where language fails in science, we can use code and we can use visualization, and it's more of an assistive device and a supplementary device than it is, you know, an ends. I guess I find it more to be a means, I suppose.
Yeah, yeah, super interesting. And hey, Arvin and Rohan, if you don't mind, I'm just curious, would you mind starting a quick poll? Whenever you have it ready is fine, but I'm just curious, would you do a quick poll that would ask the students if they used the Jupyter notebook before this class? I'm just curious.
Yeah, that's a cool question. I'd also be curious to find out who uses like VS Code, who uses Classic, who uses Lab, Spider.
Yeah, that'd be great.
Maybe.
Yeah, so Arvin and Rohan, if you guys don't mind, you know, no rush, take your time. I know it takes a minute, right? But if you could get 2 poll questions ready. One, have you used Jupyter before? And then one, would it be fair to say, Tony, what IDE do you use? Something like that?
Yeah.
Okay. Okay, I just want to make sure I captured. Okay, cool.
Yeah, that's great.
Okay,
So,
cool.
We can go for do you use Jupyter right now, and then I'll get up a poll for the VS Code and stuff.
Yeah, great. That'd be awesome. Thank you, guys. And yeah, no rush. Just whenever it's ready is perfect. I'm just curious. It'll be a cool way to see what students' backgrounds are.
Well, it looks like Sai just upgraded their vehicle today from a notebook to Jupyter Lab. Isn't the doesn't the engine purr a little nicer, a little smoother there?
Nice, yeah. I'm still on the notebook. I got to try it. Some of the members of my team really like Jupyter Lab. I haven't fully made the switch yet. I'm kind of back in the old days.
Well, Christina is very surprised right now. Oh, Sai, it's just different. It'll get it's better over time.
That's funny. That's funny. So, Christina, you're not required to use the Jupyter Notebook by any means. You can do everything in this course in Jupyter Lab, of course, or you could use an IDE if you wanted to. I think when you're reviewing lecture notes, you're going to want to use Jupyter just to view them, but you're not required to. I'd say take what you like of it, try it out, see what you like. But yeah, it's not a requirement of the course. Good question. Cool. Awesome. My next question, I put together a few questions, and I'm happy to go wherever this ends up. And this kind of is related to the last one, but if there's anything more to say about it, I'd love to hear about it. I think you were kind of just getting into it, Tony. Can you talk a little bit more about literate programming?
Oh, I'm sure I can talk plenty about literate programming. So, have you read the paper before, Stephen?
Donald Knuth's paper. I read his book.
Yeah.
Yes. Yes.
The Knuth Web paper.
No, I've only read the book called Literate Programming. I don't think I've read this paper.
Oh, this paper is a delight. Every paper should shoot for this level of spirit. My favorite part of this is I'm imposing a moral commitment to anybody who hears the term literate programming. Surely nobody wants to admit to writing an illiterate program, right? And I think another key aspect to this is this little diagram here where there is a language that can be both a program in Pascal and a program in Tech, or a program in Python and documentation in Markdown. So it's sort of this idea of writing a paper that has both the intent of being readable and also executable. I think it's just, I think that literate programming was like a pre-science idea in the sense that it didn't matter until we started to get a bunch of data. Let me go into here, testing notebooks. So this is a blog that I continued for a while. It's all made of Jupyter notebooks, and we can import them all. But, it winds up being this mix of code and documentation in between the two. And neither the intent is for it to be a code specifically, or the intent is for it to be documentation specifically. It's kind of this place where, you must talk in code and in data. And I think that that's a specifically important task for the data scientist, is to be able to responsibly learn how to communicate their work to other people. And this idea of peppering in narrative with your code, you can think about it. Well, maybe you're like, who am I writing for? And it's write for your future self. Sometimes the code, sometimes you can wait for other people to write the code that you want to use, but sometimes you have to come and kind of write it yourself. I think this idea of literate programming is more about looking at a program from the position of language, which a lot of us are more familiar with, and the position of code, which does take time.
Awesome. Yeah, really cool description. Absolutely. Yeah. And I think that It's interesting because, code, right? And there's another good quote that kind of comes to mind about, what is the purpose of code, right? And it's you're telling your computer what to do, right? But at the same time, you're also it's a way to communicate with other humans, right? So other humans are probably going to read your code if you're on a team or if you're doing an open source project, or that other human, like Tony said, it might be yourself in 6 months, right? And I'm sure I've certainly had this experience a bunch of times where I write some code, come back to it 6 months later, and I'm like, oh, what the heck was this guy thinking? This guy's an idiot, And it was just me 6 months ago, right? So I think this idea of literate programming, or at least part of what I recall from the book, is that it's a different way to think about programming. And in that book, Donald Knuth, he lays out really a framework and source code that lets him write documentation and code in the same go, and they can be compiled in 2 ways. One way is into, like Tony Fast said, into a tech document, so a LaTeX document, not LaTeX at the time, but basically you get your documentation and your source code from the same original work of literary programming, basically. And I think Donald Knuth's exact approach, where he used this web language and stuff, that has mostly become obsolete as far as I know. I don't think most people are using that exact approach, but the idea definitely lives on. And I think Jupyter is probably the most, even though it doesn't exactly encapsulate Donald Knuth's approach, it seems to me like Jupyter is probably one of the forefront, tools for doing literate programming today, I think. Is that fair, Tony? What do you think?
Super great. Oh, man, the segue is... I actually had to do a presentation for JupyterCon basically about this instead of not submitting. Well, anyway, yeah, so... literate programming is more about the document as a whole. Mm-hmm. So like I want to be able to import a paper by Stephen Welch and get the algorithms, but also be able to read the PDF, right?
Right.
It's literate programming.
Yeah.
But when we're talking about working in notebooks, we're talking about literate computing, which is a little bit different because we're trying to weave live computation into the narrative. It's a little bit different, right?
Right.
So when you're in the notebook and you're focused on the code and you're working with it, that's literate computing. It's really high energy. It's really expensive to be there.
Right.
Literate programming actually gives us perspective when the document's dead and the document's not being used, right?
Right.
So, combining literate programming with literate computing together actually gives you this holistic approach to thinking about a notebook that could be a code at rest or document at rest, but then it's also highly interactive at some point.
Right. Awesome. Yeah, I didn't think about that. That's really cool. So
can we keep playing on that one?
Oh, keep going, man. Sorry, I didn't mean to cut you off.
What is it? What's a notebook, right? Like what's that? Like what's the main reason? Like what's the main reason you use a notebook, Stephen? Like
that's a good question. Well, let me think way back, right? So now I'm like fully entrenched, right? So like I've been using notebooks for 8 years now, so now I can't. It's like part of my thinking, I think, so it's hard for me to get context. But let me go way back, right? So back in undergrad, I went to Georgia Tech, started in 2005. When were you at Georgia Tech, Tony? Similar time?
Oh no, I was there like 2016-ish.
Oh, after me. Okay, got it. I was there 2005, 2009. Okay, cool. So my first programming class was MATLAB. And I'm actually a little mad at Georgia Tech for teaching me a proprietary language. You have to pay a lot of money to use MATLAB, and at the time, though, it was the thing, right? Otherwise we'd be writing like C code or something,
Did you have a CD with the serial number written on it, though?
I did, yeah.
Did you? Everybody had that thing, right? And the serial number was so goddamn long that it actually took up the whole cover of the CD. It was insane.
Yeah, man. MATLAB was serious, or the MathWorks was serious about you not pirating their stuff. Mm-hmm. And for me, so I used MATLAB all the way through grad school. Went to grad school, wrote a bunch of MATLAB. It's fine, it's okay. I was okay with it. But then I founded a startup right out of grad school. And we didn't have a lot of money. We were bootstrapped. We were part of the Georgia Tech incubator. And I couldn't. MATLAB is $5,000 to get started, and then every library you want's an extra like $2,000.
Right, and you can't even do anything with it. It's like buying a tent with just the poles, and it's like not even a fabric on top of it to do science.
It's crazy, right? And I understand where it came from. It was a really big breakthrough in the 90s, these folks at MIT. I get it, right? But for me, with this little startup, I was like, crap, I need to do something else. So I spent like a month in Octave. So Octave is the open source version of MATLAB. It's not great. It was bad. So then I kind of bumped into Python, and I was like, wow, this is interesting. And then I think I kind of stumbled into the idea of the notebook. And at the time I had a consulting job as well. So I was kind of using that to pay the bills of the startup. It was my consulting job. And in my consulting job, I was working for this big company, and I had to do a lot of communication of like results and algorithms with a big team. And this notebook kind of popped up as a way to share my code, my visualizations, and my text all in one thing. And I was like, holy crap, like this is such an amazing communication mechanism. Like I can just export this as an HTML, and I can just share it with the team. And this is so much better than making a PowerPoint. They can rerun the code. It's reusable. It's portable. Oh my God, this is amazing. And then I quickly adopted it, and it was like the only thing I did, right? So I think that, to answer your question, a long-winded answer, but that's how I got into it, and I really haven't looked back, right? Just because you can blend those three things together and you can make a narrative. Ooh, I think you're muted.
You answered it right in the beginning. Yeah. You gave me a very long answer for no reason. Why do you use the notebook today? Like you have an idea. You need to test that shit. Oh, I'm sorry for cursing. You need to test that stuff. Yeah. That's the technical term for this, right? That's why I like to think of notebooks. They're these informal tests. And when you bring in this literate computing concept, you can say, all right, well, Donald Knuth was concerned with a program as documentation. Literate computing is concerned with a program as a test. And the narrative is essential to that test. So now you take these two ideas together, documentation, testing, and the code, and you really have a very holistic approach to doing machine learning and telling stories and stuff like that, right? Because if we're going to tell a story about COVID in March, that story is going to change in June. And we need to know if this model's still failing, if it's still running in production haphazardly. We need to be, and these things need to be captured at the moment that they come up, right? Like we've been dealing with this, move fast and break stuff culture for a really long time, but we need to move fast, break stuff, test it, fix it, patch it up, and keep deploying this stuff. And sometimes it's difficult because it exposes the flaws in things. But when we're doing computer vision, if we get a good job at a computer vision company with millions of users, that means that there's hundreds of thousands and millions of people that are being excluded by your algorithm also.
Expand on that.
Like the people that your algorithm works for, if you have a large enough base, your company's going to cater to that base. And there's always a standard deviation to that distribution. And, how many standard deviations is your model able to, work across race, gender, culture, bandwidth, right? And all of these things are really critical parts of the story. And I think literate computing kind of gets to being able to capture it. But I also think the video is going to be really important too. Like, I think there's something to like TikTok programming and stuff like that. But, some of your best ideas are 10 seconds of life, right? And it's like, if you weren't to capture it then, it's inauthentic,
Right. Man.
But yeah, I think you should test notebooks. So have you guys heard of NBVal before?
No. Tell us about it.
All right, cool.
Well, I have not, but throw it in the chat window if you have or have not.
Okay, has anybody heard of NBVal before? Nope. All right, great. We'll go to our computer vision lecture room. All right, so NBVal is one tool. I use it all the time, and this lets you take a notebook and test it. So let's see. I'm going to switch the screen I'm sharing. I know exactly what I want to share. Okay. Sorry. I like Tony. Thank you.
That's a good comment.
He needs some of those positive vibes in his life. Okay, share screen now. What your browser's preventing you from sharing the screen? All right.
Tony for president.
All right, share screen now. All right, share the other screen. All right, great. All right, here we go. Party on. Jupyter Lab. This one's cool, Stephen. So this notebook here, if you look at it, it's like hella CSS in here, right? So since it's open, we go into presentation mode. Oh, isn't that pretty? It just gets rid of some stuff for you, kind of a nicer editing experience, right?
But what's kind of cool?
What's kind of cool is if you get rid of it, it just goes back to normal. So you can like live hack how all of your stuff looks, which is pretty neat to me.
Nice.
But let's make a notebook here. And let's go and say 10. Okay, I'm going to save this notebook. It's called Untitled 2. And then I'm going to go and pop open a terminal. So this is one of the nice things about Jupyter Lab is you can have like these multiple things open here. And now if I go to pytest -mv val and I do Untitled 2, ipynb, and I run it, nothing seems to be happening. Okay. Yeah, so I don't even know what directory I'm in.
Oh, yeah.
Let's see. Where am I? Documents. This should. All right. So, CD documents. There we go.
There you go.
Okay.
Nice.
Run it. Okay. Go. Okay. So collected one item. It found that notebook, and it, for some reason, I don't know, succeeded. But what it'll do is, it should do is if I save this and the outputs are incorrect, it validates the output of the cell versus the input of the cell. It'll make sure that the cell has been, so see it's failing. And it's saying that, right. So since my input's 11 and my output's 10, then we can do that. And like, you know how another thing too, if you all don't, I'm going to show you, how do I show this? Okay. Have you ever heard of DocTest, Stephen?
Yes.
Okay. So DocTest is actually a literate programming style of testing. So in Python, we'll have a function. Oh man, I got a good demo for you. Let's rock and roll. All right, I'm gonna give you a literate programming demo. This is something that I've been working on in my own time. I wouldn't suggest it to anybody. But I'm going to give you all something that you can kind of walk away with here. So what's the best example what's the simplest code we can write? We're going to write FizzBuzz. Okay?
Okay.
So we're going to go and we're going to put this URL in here. And I've like hot rodded this thing. So, I just get the iframe, which is very nice. And basically what we want to do here is we want to write some function, FizzBuzz, that goes up to like, I don't know, 36, right? And then this is the output of it, right? So that's our goal. And this is DocTest syntax. So if we go to DocTest Python, this is part of the standard library, so you don't have to add anything to make this work. So in here, you'll find the syntax with these greater than signs, and then there'll be some ellipses. But again, this is standard Python. This is literate testing style thing. But right now what it's telling us is we don't have a function called FizzBuzz. So this is actually written in my literate programming language. So we're going to do FizzBuzz, and that goes to I. And then we're going to say that for I, I won't be a jerk, in I, range I. Now we're going to yield J, okay? So I don't know if you all have ever used the yield statement, but when you yield something, you get a generator. So that actually isn't the result here. So we can take a generator, and since it's an iterable, we can put it all together, okay? So now we're going to say, hey, let's join all of these guys by a comma and a space. And then we're going to join that, and we'll see the results. Sequence item expected a string, but it got an integer because I'm actually yielding integers here. So let's just go and do one last thing here, a little functional programming smush in here that turns everything into a string. And now we're actually getting some output. And what it's saying is that it expected the result that we got from Wikipedia, but it's getting this. So let's get rid of these quotations real quickly. So basically, we're going to just throw a little print statement in here, and that's going to ensure that our quotes go away. And we want to make sure that we start from 1. So now we are getting a series that goes from 1 to 35. And now we're going to have to write our FizzBuzz pattern. So we're going to say if not J is divisible by 15, then we're going to yield FizzBuzz. Okay. And then if it's not divisible by 5, let's see, what's the 5th one there? That's buzz. All right. So we're going to buzz. And then if that's not true, then when it's 3, so Stephen, you're going to have to tell me if I get a programming job after I complete this, because you know it is the industry standard these days. So now we go and run this, and I don't know why it's failing.
Oh, it looks pretty close. Are you missing the very last one?
Close, right?
Do you need to go to I+1?
Let's go to 100.
Okay.
And it succeeded. And because ellipses actually are a little thing in here. You can put ellipses as like a catch-all star wildcard.
Oh,
So
wow.
basically, you know, it just counts up to here and then takes everything else. But you know, we just wrote a function that this function generates the fizz buzz pattern. But this is kind of a real, you know, sort of bespoke kind of literate programming approach that I kind of take to things where I'm thinking about the test rather than, or thinking about the test and the narrative, and then the code sort of comes last.
Right, absolutely. That's super cool. Can you talk a little bit, and we don't talk about test-driven development or anything like that in this class. It'd be nice if we did. It's certainly something that I've found to be important in my work, especially when you're working on a team, you know. And I'm not sure of the students in the class, like how many folks have had courses where you talk about testing and things like that. But can you talk a little bit about that, Tony? Like, you know, why testing is important? Why can't I just write code, right? Why do I need these tests?
Oh, right. So, you know, one of the nice things about when you think about a literate program as a document, you know, you're not going to read a book that like just is illiterate in the middle. You're going to stop. So like a notebook should also, you know, restart and run all in that sense. So in the world of Python, PyTest is kind of the industry standard.
Right.
So tests really do help you write better programs. There's Hitchhiker's Guide to Python Testing, I think, is another good resource here. Hitchhiker's Guide. Testing your code. If this one has a cat, yeah, this one's it. So you know, a testing unit should focus on a tiny bit of functionality. Tests should be independent. There are ideas and disciplines behind writing tests. But you know, what's typically interesting, I think, from a scientific perspective, is that when we're making a hypothesis, it's something we're trying to test. And can we unit testing is a formalized way of testing. Working in the notebook is an informal way of testing. If you add that --nb val thing, you've just formalized something. And you know, that little bit of formality can add a lot of value to your work. So I want to show you all one thing here. So let's go over to my console that I just had open, and I'm going to grab this code and I'm going to move it over into here. Let me just put it in this literate programming kernel. Okay, good, super, great. I is not defined. I don't even know where that is happening. Oh, yeah, that's why. Okay, it's a tabbing issue.
There you go.
All right, so now we're good. So now we've got FizzBuzz. So if we look at FizzBuzz here, FizzBuzz has a doc string to it, right? So if you shift tab, you can see that this function generates FizzBuzz pattern, and here's the thing. So if I was to use this, when I'm using Notebook Live, it's actually running in the main context, right? So like when you're making a machine learning application, the last thing you do is make your main CLI. But when you're working in the notebook, you're almost working backwards. You're almost working from main. So what we can say here is if name equals main and import doctest, print doctest testmod. So these are just functions that I know. And if you notice, our tests are actually failing. Remember last time you were like, oh, let's just add 1 to it, but I added 100 to it because of this here. So there's a argument on here, if we shift tab, called options flag. So if we do put the options flag on here and then add ellipsis, now it works, right? So if I was to come back to this later on and say, maybe we change the whole convention, and if I was to go and restart and run all this notebook here, which is the double arrow, when it gets to the bottom, it's going to tell me that it failed. And I think that there are really reasonable ways to put kind of checks and balances in your code by saying, hey, I'm not going to finish this project or send this code until I'm comfortable knowing that my code restarts and run all. But Tony, sometimes I load in all of this data. Get yourself some research data. Cache some things. Memoize some things. Don't work off of cloud data. You should be able to work while you're camping. I think that some of these formal testing practices put into play with machine learning have better abilities to, wind up in daily pipelines and be checked in continuous integration and health metrics and stuff like that.
Absolutely, yeah. I think on my team too, like we really find that the tests make us a lot less afraid to change stuff, right? So like once we're in production, we work in manufacturing, right? So like the code that the machine learning models that we deploy like are actually, they're on production lines and factories making decisions, right? And if our new model isn't as accurate, we're going to actually break a bunch of real world stuff and cost our customers a bunch of money, right? So like that can make you really scared to change stuff, right? So by investing in those tests first, right, and having a nice test suite, then you're way more confident to make a change because you know that if your test pass, there's a good chance you're not going to break everything at your customer's factory, right?
Well, there's that too, but you used to work in self-driving cars, right? Like that thing can run into kids and dogs, and it's crazy, right?
And I'm not convinced you actually can fully test the autonomous driving, stuff. Tesla does an okay job. They do a good job. I mean, they do. But they have a bunch of regression tests they run basically, right? Which makes sense. But you still really can't test everything because it's such a big.
Of course. But that's it's like on one side, you can test nothing, which is basically peer review, right? Like science would do better by having more formal testing embedded into their peer review process than they do. And machine learning would have better results if they could apply more peer review process to what they do by different people rather than like people, because there's a lot of potential bias in some of these things, right?
Totally. Yeah, absolutely, man. Definitely. Hey, I think our polls are ready. I know we made those a little while ago, but I just got to chat. I think. So, Arvin and Rohan, go ahead and launch maybe that Jupyter one first, if you don't mind. Let's see how the class's background on Jupyter and IDEs. Cool. So the first one, do you use the Jupyter Notebook? And what we mean really is, outside of this class. Before this class, because I know in the class I'm making you use it, right? Or I'm not making you, but it's part of the class. So really, outside of this class, do you use the Jupyter Notebook? I'm going to say yes. Oh, actually, I can't because I'm a panelist. Yep, never mind. But excited to see what you guys say. So take a minute and we'll see how the poll comes out.
Cool.
And we only have 20 minutes left. That's crazy, man. This class goes so fast, Tony. Like every time I look up, it's like there's just a few minutes left. It's crazy. So hopefully we can hit some more cool topics. Yeah, testing is such a big thing, and I don't feel like I really learned much. I had to really learn testing kind of on the job. I feel like I didn't. Now I don't have a computer science degree, right? So maybe I would have learned more with that kind of background. But in your background, Tony, material science, right?
Yes.
That's cool. Yeah. Right.
And for me, I realize that in material science, often what we're doing is we're trying to put words to information and pixels, stuff like that. And at some point I made a major mistake in my career, and I was like, oh shit, this software stuff looks so cool. I'm into software stuff. But I ejected myself from my field because they weren't, doing the software things.
Yeah, I think that's happening in a bunch of fields. My background's electrical engineering, and I don't have anything against EE, but when I went to grad school, it was all the cool the things that were interesting were all very machine learning software related.
Right.
Totally.
Yeah.
All right.
Yeah.
Good. We got our poll. So 79% of people use Jupyter outside of the class. Cool. That's more than I expected.
That
That's pretty cool.
rules. Oh my God, that makes me that I've been so down on society today. That just made me so hopeful for the future. God bless you all.
That's great. Well, no, UNCC is a really cool place. It's a nice, diverse campus. You know, I think we have a lot of folks with different backgrounds and different skill sets, and it's been a really cool place. I really enjoy the projects you guys do. Like we've seen some really cool projects in the class. Cool. When you guys are ready, Arvin and Rohan, if you'll launch the next poll about the IDE, that'll be cool to see as well. Thank you, sir. All right, how many options did you guys give us? Wow, a bunch of them, cool. All right, yeah, I use Sublime and Jupyter Notebook. All right, yeah.
Nick and I gave this ridiculous talk the other day where we tried to compare Jupyter Notebooks to skate parks.
Nice.
It's awesome.
Nice. That's awesome. Oh, Abhijit says Atom. Yeah, we didn't put Atom on the list. That's a nice editor as well. I used Atom just a little bit here. I guess we didn't put like Vim either. If you're like a hardcore, Vim user, feel free to throw that in the chat. Or if there's something else you use, feel free to throw it in the chat as well.
Atom? Microsoft bought Atom. They're killing it. It's like that flip phone, that flip camera. Emacs. Somebody's
Emacs.
Walking
That's
around
nice.
With some pride.
Sean, that's pretty cool. Yeah, that's awesome, man. You are. That's pretty serious. Notepad++, nice.
No, get out of here.
Well,
no,
this
Thomas,
is super.
Are you really using Notepad++? We've got to have a talk if you are. Oh my God. Okay, we're gonna have real talk about this.
Nano? Okay, not really. Just kidding. Yeah, Nano would be crazy. Holy crap.
Whenever I get stuck in Nano on like a remote machine, I have no clue how to get out of that. I hate that. Like,
Vim is worse. Yeah. All right, we got our poll results. So 27% are using Spyder. I think the most popular is Jupyter Notebook at 69%. You got 53% at VS Code, 16% at Jupyter Lab. So that's the smallest right now. Sublime 31%, and then PyCharm. And PyCharm is very popular, 45%. Very cool. That's awesome, guys. Yeah.
I think PyCharm has a good student bundle. That probably helps, right?
Sublime is dope. Yeah. So yeah, Supam says yes, a good student bundle for VS Code. Nice.
Yeah.
Oh, sorry, for PyCharm. Sorry.
Yeah.
That's awesome.
PyCharm's expensive if you don't go to school no more. It's like MATLAB.
Yeah, totally. Well, that's awesome. Well, as you can tell, Tony and I could like talk about this stuff all day. We have like 20 minutes left. I want to make sure, this time really it's just like I said, it's awesome to have a guest lecture, and I want to make sure you guys are able to get your questions in. So as we keep talking here, if you have any questions for Tony, please throw them in the chat.
Yeah.
We didn't talk about a bunch of Tony's background, but material science, and then he's worked on a bunch of these open source projects. You worked for Continuum for a little while, right? Who makes Jupyter?
No, none of these places make Jupyter. They always have like people contributing.
Sorry.
It's open source is a broad world. Let me see. I need to talk to you about IDEs, and I need to connect my material science to IDEs. Man,
Sure.
I always go for these like long temporal connections. But anyway. So when I was in material science, what we're trying to do, it takes like 10 to 20 years to get like a piece of fabric into an aircraft. Like all of the testing that they have to do to ensure that that is safe enough. It's like insane and costly to get new materials to market. So they want it at half the time and half the cost, because who doesn't, right? And, I've been plucking at models, I've been plucking at algorithms, I've been plucking at software, I've been plucking at companies and occupations and trying to figure out, what's going to do that. And the only thing that I come to the conclusion of is that we need to do more with a keystroke. And I really encourage anybody who's not using a modern IDE to take some time, take some self-care, stop rushing, and sit down and get your house in order. Work together. You have a big class. There's a lot of different people. There'll be different approaches, but crowdsource your best experience. Unfortunately, Thomas, I don't think it's good that you're using Notepad++, because you could have testing, you could have code completion. Like, I don't want to write a full API statement. I want to write part of it and tab it, write part of it and tab it, right? a lot of data science is being able to copy and paste. It's being able to think at an aggregate level of code. It's being able to think at that cell level rather than at the individual pieces of code. Software engineers think at the individual pieces of code. But when you're doing data science and you're doing implementation, you got to be thinking bigger to get ahead of and solve the problems that you are. So it would be super cool if folks could share their experiences later in the class about how they've improved their ability to, simulate the class like an organization somehow. It's like, what's the easiest way to help with this? But please, pandemic is hard.
It is.
You should be working efficiently. Programming should feel good. And if you're struggling and it's taking time and it's tedious, then it's going to be difficult to succeed.
Yeah, that's a great point. And yeah, we don't really cover kind of the the workflow of a programmer, or kind of the and I think some courses will cover it here and there. Maybe there's a course at UNTC I'm not aware of that really spends time, like Tony said, kind of helping you get your house in order. But I found in my kind of university experience that a lot of those practical skills can kind of be missing from some of the more theoretical or abstract classes, but they're so important. What kind of workflow works for you? What are the tools that are really going to help you be more efficient, be more confident? And yeah, the modern IDE makes a huge difference. Can you expand a smidge, Tony, on the keystroke thing? I thought that was really interesting. So for you, you're thinking that, hey, the limiting factor here really is what can I do with a keystroke, right? Is that kind of what you were saying?
Yeah, man. I want to. So I actually have this weird habit. Everybody dings me for it. I think you've dinged me for it one time before. But if you notice, when I'm writing code, I always just kind of like start with like a tab in. And the reason for that is that I can go and hit the single letter M and run it, and now it looks like Markdown. Or I can go and I can remove this tab and I can run it, and now it looks like print. But you do these small motions and they can have big changes. And if a lot of people will think, let me from pandas import data frame, right? And that's just one thing that lives on pandas, right? I mean, pandas has len, dir. Like, what are you missing out on here? Are you saving, and I don't like these conventions, import pandas as PD, because for new people, you don't talk about things this way. Import NumPy as NP is not literate. Import NumPy, pandas, right? Like, it's very weird to me that when we work on these notebooks, we start with all these hella imports when it's not actually interesting or important to the story. It's actually just kind of a footnote. So, at this literate programming level, you start to think this way, where it's like, okay, I want to use these things in a way. So I actually have this interesting idea in here. So there is a library NP that is for arrays, right? So we run this and it's fine. And if I were to go and run this now, I actually get an error, which is pretty cool, right? And it says NumPy is not defined. If I import NumPy, my test pass, and now that works again. But like, when I look at these two things, I'm trying to think, well, if somebody comes to this and they're not privileged of having the experience of the scientific community, which is going to read better? And I really think it comes down, like, efficiency is fragile. But literacy is the thing that we must make a little bit more robust.
Right. Yeah, absolutely. I didn't really think about this while we were talking, but I think maybe one thread here kind of is that the if you work in these fields, or even if maybe not even work is the right word, but if you're using these tools and stuff, like the programs you write are kind of an extension of the language that you. It's a way to communicate, just like the language that you use every day, right? And I think it's really maybe. It's easy not to think about programming as like a language in the sense that English or whatever your native language is, but if you start thinking about it that way, then there's a whole other, I think it really changes your perspective on how you use these tools and how you, how you interact with the computer, basically, right?
So, it's I've actually I'm going to be personal with you all. But since we last talked, Stephen, I went to a doctor and got some testing done and dealt with my mental health and stuff, and I found out that I had ADHD and autism and anxiety and depression. And ever since then, I've been really able to think about being an autistic adult and having trouble with communication from the perspective of the Notebook, where I've spent this whole life in science surrounded by terabytes and gigabytes of data, and I've been asked to explain it to people, and people are frustrated by my inability to communicate it. And once I got the Jupyter Notebook and I learned that it's a supplementary tool for my literacy, I find myself able to communicate. And and now I try to put my best foot forward, where I've learned to live demo really well. So I actually have the ability to supplement my language in real time during meetings, where it's like, instead of saying, hey, let's go off and do this, it's like, no, we're going to do this right now while it's happening. And, the Notebook, your IDE, the way you set up your life, it's how you communicate with the world. And I think the Notebooks really help do that digitally.
Wow, that's awesome, man. That's so important. That's really neat, because like, it really is about how you communicate at the end of the day. You can have, this amazing code, but if it's only in your head, then it's just, there's only so much you can do with it. And that can be really frustrating, because you can feel like you're not heard, right? Or that, people don't understand, your way of seeing stuff, right? So yeah, it's an extension of how you communicate with other humans, right? That's pretty cool.
There's this beautiful paper. I'll try and find a way to share it. I got it off of Sci-Hub because that's the best place on the internet. But it goes and talks about the difference between science versus literature. But there at the end here, it gets slightly hopeful, paternalistic. Yeah. He talks about here it is, a third margin which science must reconquer, that of pleasure. Right? And lyric programming can be really fun and really expressive, and I encourage folks to practice expressing themselves with these mediums if they do find, like, the fact that like 80% of students are using it outside of the classroom, it's clear that it really helps.
Totally.
And keep on refining who you are and how you want to communicate.
Yeah, totally. That's awesome, man. Very cool. Well, we only have a few minutes left. Monica asked, I think, a cool question. She said, how do you deploy ML models into production? So a little bit of a shift here, but I want to make sure we look at these questions. This is a cool question too, like setup technology. So I have some answers. You want to talk about that first, Tony? What do you think?
Well, I mean, first you got to learn some CI. You got to learn a little bit of GitHub Actions, right?
Yeah.
Oftentimes.
And what is CI? What is CI? Just in case some folks don't know.
Continuous integration.
Totally.
Half the time, half the cost, more with a keystroke, right? So when you commit, if you commit something and it's not running tests and it's not generating documentation, you're missing out on opportunities, right? Like what needs to happen now, organizations have gotten really good at aggregating their knowledge. Individuals need to be able to have the same affordances and benefits that large organizations have. So like things like testing your code, producing documentation, and have you seen the Jupyter Book project, Stephen?
No. I mean, that sounds really cool.
I'm going to show you that. I actually am deploying some of my docs with it. So the cool thing about these docs is that they're actually written in my Lyric programming language. This is a Markdown document, and this is what it looks like. It's pretty nice you can search. So if we search for like Tangle or New, so we get this stuff out of it, and it's very cheap to have. So I'm using Read the Docs, but the executable book project, remember I talked about Fernando Perez earlier? Him and his team have been working a lot more on this project. So, Stephen, if you have a class and this was used in a lot of the data science classes at UC Berkeley. So if you have a class, this is a really fabulous way to actually go and deploy like book PDF content with Markdown and notebooks and stuff.
Yeah, that's so awesome. Yeah, I think that's super super interesting. I was hoping this year to actually do some kind of automatic documentation / book generation for the class. I haven't had time to work on it, but I think that's a super cool thing to do. That's awesome. And then
Hey, why
just to build,
don't we can get together for half an hour and make that happen sometime if you've got a repo, man.
that'd be awesome. We got 7 of them for the class, and the notebooks are good. But yeah, man, that'd be awesome. Cool. And then one other just comment on deployment really quick. So yeah, I totally agree with everything to what Tony said. And he made a good point about how like kind of the bigger companies have better tooling around this. I think a fun example is that at Google, for example, do you know how many repositories Google has? This is a fun trivia question. So Google has
thousands.
One. They have one repo.
Ugh.
They have just insane tooling to like. Isn't that great? I know. I guess thousands as well. I had no idea, but they have this really awesome, like, incredible tooling around all the code that they write that does like automatic testing on like. There's some crazy statistic where like when a developer at Google submits a line of code or something or commits it, it's run against like hundreds of thousands of tests. It's crazy. But there's a real need for that for smaller organizations as well. You know, we've got a decent amount at my work, but we're only a team of like 5. So like it's definitely an area where we need improvement in open source. And then just kind of like nuts and bolts tactical, Monica, on your question about deployment into production, I would say the technology, you asked about technologies, like the technology that we use is definitely Docker. We're not going to use Docker in this class too much, but we use Docker, heavily. And I would think that if there was one technology you're going to look at for deploying ML, it's probably Docker, and then maybe Kubernetes. Anything to add to that, Tony, as far as like specific technologies for deployment?
Dask.
Sure.
There's a bunch of cool companies around that. Prefect has some cool things. I mean, like a lot of this stuff, you need the UI management there.
Right.
Yeah, it's tough, right? Like, I mean, in this stuff, there's a lot to know, and there's kind of 2 options that you have. You learn it all yourself, right? Which is
right.
what we've kind of had to do over the years. Like,
right.
I know so many things I don't need to know it, but I mean, maybe it like add it up eventually. But now here's the next. I'm gonna jump in with one last little bit. One last screen share.
Yes, please.
All right. So I gotta tell everybody about my band, right?
Totally.
So I've got a band, everyone. We're called Deathbeds. We write code. So orbiting the project Jupyter. So like we've got a bunch of fun, crazy things. Like we've got good fonts in Jupyter Lab. This one here, Steven, this is a crazy place. This is a binder. Have you seen Mamba yet?
No.
Okay, Mamba is a conda solver that solves in like half the time.
Whoa.
Use Mamba. Yeah. So this is our environment. This is a binder. So it's got like over 100 different packages on it, and like 20 different extensions. So you can click on one of these links and it'll send you to a binder, and there's tons of fun, silly things over here. But, I mentioned programming being fun. I think that it's important to have fun, because when you're having fun, you're learning.
Oh, yeah.
And you're having trouble having fun while you're programming, program with somebody else. And that's why I have a band with it, right? Because it's as much fun as it can be to program alone sometimes. It's much more fun to like learn how to do it with friends and find teammates. Different people are going to be interested in different things, So like, I don't know. I think if I had to go back and this is like if I had to teach the future class, I'd give team projects, right? Where it's like, let's simulate your little organization. Everybody has these different responsibilities. And, another thing that's important too is empathy in this, right? Because like everybody's got, and data science is a team sport, right? And like being understanding of everybody's capacity and timing and all that kind of stuff. It's
totally.
It's not technical. As much as we talk about the technical aspect, there's so many communication problems.
Yeah. Absolutely. Yeah, that human part is totally critical. I agree, man. We're almost out of time, but yeah, I super agree. We do a group project in this class kind of that's the big part of the reason we do it, basically, right? Because that's really where it gets interesting. And also, I kind of think, and this hasn't always been true in my career, but sometimes it is. And the times that it is, I'm really happy. Like, I think when you are having fun and like really kind of taking ownership of the code you're writing and not just taking it super seriously, a lot of times you actually end up with a better outcome, in my opinion, because you're just going to be more creative, And I know that it's the middle of a pandemic. You probably have some hard classes. Like, I'm sure things are stressing you out. But maybe this is a little bit of a reminder that it doesn't have to always be super serious. It's definitely not all about grades. If I went back in time, I definitely wish I had worried less about grades. And this stuff can be really fun and cool and just beautiful, you know? So yeah. I hope that's, I mean, hopefully that comes through in this course a bit, and it gets you hopefully thinking a little bit in that way, because there's just so many different ways to think about this stuff, you know?
Did Steven go away?
Yeah, I think his he has
Oh wow.
That's
okay. Having fun. Oh yeah. So what time's the class end, guys?
It's just about to end right now.
3:45?
Yeah,
well, great. I hope you guys had fun. Talk more. No.
Yeah, it was a really good session for us.
Well, I'm glad. Please, no, you're lucky to have Steven. Thank you all. If you want to find me, I'm on Twitter, DocFast, DocFast.
Hey guys, sorry I got cut off. I'm back, but thanks everyone for attending, and thank you, Tony.
Tony, your audio is off.
Everything went to heck. Anyway.
I totally lost my connection. Can you hear me now?
Yes.
Awesome. Tony, thank you so much, man. I'm sorry I got cut off at the end. I really enjoyed your lecture. I think everyone got a lot out of it. Thanks a lot, man. That was a lot of fun.
Yeah, let me know if y'all post this up on the internet or nothing.
We will. Yeah, we'll definitely let you know. Thanks a lot, Tony.
Hey, y'all. Be well.
Yep. Thanks, man.
See you.